Good morning students. Up to last lecture we have studied about how we have to categorize a given substance into whether it is an element or compound. Simply I told you in last lecture that if only one type of atoms, that are the identical atoms, are present in an substance, in any substance at that time, that substance is simply called as an element. Okay, what? Only identical types of atoms are present there. At that time we can say that the given substance is what? An element. Okay, if two or more atoms are combined to each other to form one molecule of a substance. I already told you many examples. For example, we see today that is suppose H2SO4. Okay, here what happened? Two hydrogen, one sulfur and four oxygens are combined to each other to form one molecule of sulfuric acid. What? Sulfuric acid is the formula of sulfuric acid. In the one molecule of sulfuric acid, three types of atoms are combined with each other, that are the hydrogen, sulfur and oxygen. Okay, so such a substances in which two or more types of atoms are combined together to form one molecule. Okay, such a substance is called as a compound. Okay, and element is not simply only one type of atoms are present there, that substances are called as an element. Okay, so in that whole story, in case of element or compound, one thing is very important, that is the atom. Okay, and this atom is simply what? Atom is simply the smallest indivisible part of any substance, that simply called as a atom. So here it is the smallest indivisible part, we cannot further divide it. Okay, it is the very smallest part of an substance. Then now we have to, today's lecture we have to study some theories that is proposed by some scientists about this atom. Actually, now in modern science, the whole study of atom is carried out now. Okay, and some study is progressing. Okay, so today if I ask you what is the atom, then you tell me that atom has a nucleus in its center. Okay, this is the nucleus of atom and it is positively charged. Okay, so today's modern atomic model says us that atom is consists of nucleus and extranuclear part. This is the nuclear part, and outside of the nucleus it's called extranuclear part. Okay, this is the nucleus, and whatever remaining rest of the part of atom is called extranuclear. Okay, outside of the nucleus, that is the extranuclear part. So today's atomic model, that is the modern atomic model, states us that the all positive charge is gathered inside the nucleus. Okay, whatever the positive charge that atom has, that is placed inside the atom. Okay, all negative part, okay, that is the electrons. Whatever the electrons that atom has, that all electrons are revolved around this nucleus in somewhat particular positions. Okay, that we call as a particular shapes. Okay, so today's model tells us that the atom is made up of first nuclear part and extranuclear part. In nuclear part, nucleus is there, and that nucleus made up of all the positive charges. Okay, there are three types of elementary particles which are present in nucleus. First of all, that is the proton, then neutrons and electrons. Okay, now these protons, you have to remember, have positive charge. Protons are positively charged elementary particles. neutrons have no charge. Okay, neutrons are simply neutral, they don't have any charge, so that's called as a neutrons. Okay, and third particles are electron that have negatively charged. Okay, negative charge. Look at this atom is made up of these three elementary particles. Okay, first of all, proton. Proton has positive charge. Okay, then neutrons. Neutrons has no charge, and third is electron. Electrons have negative charge. Okay, so these three things we have to well remember. We have to use this up to your some further higher studies. Okay, so these are the general basic things that will bear in mind. Okay, so proton positive charge, neutron no charge, and electrons negatively charged. Okay, so here atomic models, modern atomic model tells us that whatever the positive charge means simply what? Proton or positively charges. Whatever the positive charge an atom has means whatever the protons that atom has that place inside this nucleus. Okay, and nucleus is centered a place at the center of atom. Okay, so it is the very smallest. Okay, the size of nucleus is very small. Okay, the size of nucleus is 10 raised to minus 10 meter. Okay, that is the size of an nucleus. Okay, very small. Actually atom is very small, inside that nucleus placed in very small place. Okay, so all the positive charge means all protons are placed in that nucleus. Okay, then tells about, we have to see about the neutrons. Okay, neutrons are also placed in nucleus. Proton and neutrons are both present in nucleus. Okay, you have to remember that protons and neutrons, that two particles are present in nucleus. Okay, proton and neutrons are placed in nucleus. Now we have to see about the electron. Electrons are actually the negatively charged particles. Okay, and that electron are revolve around this nucleus in particular shapes. Okay, so this structure, these rounded shapes are called as different types of shells. So this electron negatively charged, all negative charge of atom revolves around the positively charged nucleus. Okay, all the positively charged be placed in nucleus, and all negative charge revolve around that nucleus in one particular manner. Okay, in one particular rule, in one particular space. That a space, that a path is called as a shells. Okay, so all positive charge in nucleus and all negative charge are what? Around that nucleus. If you see the atomic structure of somewhat element, okay, so there we will find that whatever the number of protons, suppose 10 number of protons are present in an element, at that time same number of electrons are present in that element. So 10 protons and 10 electrons. Proton are positively charged, electrons are negatively charged. So here 10 positive charge, 10 negative charge. So charge is a balance on that atom. Whatever the positive charge that atom has, same equal and opposite charge of electron are also present in a particular element. So that is why elements or substances are generally what? Electrically neutral condition, because whatever the positive charge they have, same and opposite negative charge also on that substances. That is why both charges balances each other, and electrically both are neutral, positive and negatively charges. Okay, so we know, I told you first, because this atomic structure is given later part. Okay, in Bohr's atomic theory, Bohr tells about all that about modern atomic model. Okay, we tell it first because I have to tell you some stories how people describe atom before. Okay, because nowadays science is much modern. Okay, we can carry out the study of nucleus, but after 1800 century, okay, 18th century, what happened before that? Science is not much developed. Okay, not electrical equipment are there. People just suggest, okay, whatever they think, whatever they feel about the atom, they propose all that thing on their theory. Okay, and how the development in their theories are takes place and how we are come here, that actually we have to see in this chapter. So these different theories, different predictions of a peoples, that we have to see in this chapter. Okay, so directly start from here, we have to see first some theories of these scientists which are developed by them. Okay, so this is actually the modern structure of atom. Okay, that we know, but before 18th century people don't know about this. Okay, they just tell us their thinking, writing, that we call as a theory of that people, and in that first is the Dalton. Okay, so Dalton studied about the atom and he proposed his prediction of atom. Okay, Dalton tells that the atom is sphere-like shape. Okay, also the distribution of the mass is uniform all over this sphere. This sphere is rigid and distribution of mass inside this sphere is what? Uniform. Okay, inside the atom, whatever the matter that substance has, that is uniformly distributed. That's the prediction of a Dalton about the atom. Okay, also it makes other predictions, that are the all matter made up of atoms which is indivisible. Okay, whatever the matter we have, that is the means simply substances, whatever the matter that is made up of atoms. Okay, atoms are the particles through which all the matter is made up of, and that atoms are indivisible. We cannot divide that atoms. That is the one prediction of Dalton's atomic theory. Then also all atoms of given elements are identical in mass and properties. Okay, so second prediction he also made that actually not given in our book, but I told you. Okay, so one another prediction of Dalton's theory is that whatever the all atoms of any element have, that all atoms are identical. Okay, means their mass is same and their properties are also same. Identical means what? Simply exactly similar. All the atoms are exactly similar in mass and their properties are also similar. Okay, then compounds are combinations of two or more type of atoms. Okay, whatever the compounds are present, that are nothing but the combination of two or more types of atom. Then chemical reaction is the rearrangement of atoms. Then atoms of different elements vary in size and masses. Okay, atom of different element. Okay, if we take two different elements, then we will find that what? Their size and mass of the atoms should be different. Okay, so that prediction is also made by the Dalton. What? The two different substances have their atomic size and masses are the different. Okay, so these are the some prediction made by the Dalton in his atomic theory. But one thing also, Dalton expressed that is the, if we consider this is atom and whatever the matter that atom have, okay, that uniformly distributed over the atom. But actually this is the wrong statement of the Dalton, which is said by the Dalton. That is, Dalton says that whatever the matter in an atom, that is uniformly distributed through over the atom. But actually that's the wrong statement, because Sir J.J. Thomson later find out the negatively charged particle that we called as a electron. Okay, so through that they tells that this is not what, this is actually not true. Okay, uniformly, whatever the matter that is not uniformly distributed, that they prove with the help of this negatively charged particle, called it electrons. Okay, so how they prove it, that we will see in next part of this chapter. So that is the plum pudding model of J.J. Thomson. In that we will see all that part. Okay, so first of all in this we have to remember actually what is atom. Okay, atom is smallest indivisible part of any substance, just simply called as atom. Then what are first, we have to see different theories in this chapter. In the first theory we start, that is the Dalton's atomic theory. In that Dalton tells us that whatever the matter is made up of, that is from the identical. If we take one element, then we will find all the atoms are identical in mass and size. Okay, for one atom. If we take two different elements, then their size and masses may be different, but for one element, size and masses of an atom always identical. Okay, so also atom is a rigid sphere. Okay, whatever the matter inside the atom, that is uniformly distributed. But this is actually not, you can say that right, that is tells us, or that is proved by the Sir J.J. Thomson in that second model. Okay, first of all, whatever this Dalton's theory, that is studied by the Sir J.J. Thomson, and after that they find out some loopholes of that atom. Okay, and after studying that they form their own theory. That theory we have to see in the next lecture, but for today we have to see what is the atom, modern atomic model, and we have to compare now how science develops day by day as time passes. Okay, people makes their different theory, propose their different theory, but actually now today Sir Niels Bohr that proposed exact today's modern atomic theory that we use now today. Okay, actually how that journey is going from day by day, that actually we have to study in this chapter. Okay, remaining part we will see in next lecture. Thank you.